bt. This one will be as minus a square another one is this. Okay, so sometimes I found myself this one, the two are commonly used in particular for vibration systems. So I believe in your last homework you should be able to do it. Any questions? This one is the second shifting theorem. The difference is this. For the first theorem is we multiply the exponent functions in the time domain. For the second one, we have the multiplication of exponents in the S domain. So that kind of a little bit different. But anyhow, those one provide us the formulas. And for example, here we can try is like this. For example, if you are dealing with functions and like this, then its inverse Laplace is like this. And what is h? The h function is this. It's a t, and this is h of t, and that function is this. The value is 1. So basically, this is simply is what we call the unit step function. And h t minus a simply is a delayed unit step function is this. We delay to when time equal to a, the magnitude equal to 1. The step function didn't fire up until reaching the certain timing point. So this is ht over a. Okay, so this one sometimes, why they call it h, sometimes the people call it, it's called the Heaviside function. I believe this is the name of the person, so they simply take up his last name. Okay, whatever. So basically that is a delayed unit step function. And so anyhow, so here we have the function like this. So that means and what is ft? So for example, if we have a general function, ft is something like this. Okay? And what is ft minus a? So simply is this, you shift these functions offset to here. So that means if I can copy and paste, and I will copy and paste the curve to here. Okay, so that is ft over a. So the difference is this one, this is a shifted functions from the t equal to 0 to here. Okay, so that's the meaning of those terms. So for example, here for this one, we know 1 over s in the Laplace transform is 1. Okay, and then we have this one, basically again ft. Right now, again, this is the 1 over s is Laplace transform is of ft equal to 1. So basically exactly equal to this. So ft equal to this when we shift it, so that is this function here. And that is demonstrated by this example. We can try this one, see what happens. Why I spend time to go over the Laplace transform? Because later we have transfer functions, and we're going to do the transfer functions and then to describe the control systems. And then to the final step, we have to convert it into time domain to characterize its time domain response. So that means all kinds of the systems you could encounter, and then here I show you is a few simple typical examples you might see down the road. So again, for this one, we want to solve for is the y of t. So that is our goal. So here again, we take Laplace transform. So Laplace transform of ft. So right now I'm trying to get the Laplace transform of this one. So ft described by this. Let me draw it here. So this is a time domain, and here is ft. ft equal to 0 before the time equal to 3. So basically the ft is like this. Sorry, not that. It's ft. Okay. So for ft, we have is can you see basically this line? Let me extend it here. So basically this straight line representing is this function, right? But somehow this region didn't fire up and didn't take effective. So basically here we can use the Heaviside functions, and that take effective when t becomes 3 seconds, for example, then this will become effective. So basically, these pieces from here to forever, these pieces can be represented by this. It's kind of piecewise linear function. It might look not so familiar to you, but again, most of the time, this is the linear function we are familiar with, but this is a piecewise. Basically, we use this. Okay. For this one, we arrange, and again, I want to have this format be up here. So here I want to try is this. I want to match into the format in t minus 3. Here I want to have the t minus 3 this format. So here I minus 3, I need to plus 3 back. So that is the 3 times ht minus 3. So here I minus 3 portions of this. I put it back, and that equivalent to the original. So once we have this, so therefore we can do the Laplace transform. Stop. So now look at this one. The Laplace transform of this, we can apply these equations. This equation is right now for this case, right now we can compare A equal to how much? A equal to 3. This is our scratch informations. And this is ft minus 3 equal to t minus 3. So therefore, that means ft equal to t. Okay, so taking out this one, so therefore f of s, which means is the Laplace transform of t, is s squared. Okay, so right now we have everything back to here. So in our formulation is e minus as here. E minus as, a equal to 3. So e minus 3s is s. And then this one is what is f of s? F of s is 1 over s squared. Okay? So the red one here, I write my scratch and try to match with the format. I just simply take whatever the information necessary. If you compare this one carefully, I think the essence of this calculation is here. Okay? Okay, and now we work on this one. So now it's 3, and that's the constant we can take out outside this. And now you can see this is the, again, one more time. For this one, again, this is supposed to be, for this case, and again, a equal to 3, right? Okay, a equal to 3 because ht minus a. From here, I identify ht minus 3. I identify a equal to 3. And now for this case, that one, the ft minus a is the constant 1. So basically, this is a time constant function. This is 1. So from here, basically, here is equal to, I mean, this term here will be equal to e minus 3as. Okay, and this one. So let me rewrite. So basically, the whole thing is here will be equal to e minus 3 as 1 squared plus 3 times e minus 3 as this one equal to 1 over s. Okay. Here, this one equal to plus 1 equal to s. Okay, so right now we have everything, then we can combine. Let me write up here. So by combining everything, plug in the initial conditions, and then let me skip out the detailed process. But here you can find the s squared and s squared plus 4 and 3s plus 1 times e minus 3s. That is ys. So here again, I have introduced the plot transform of this, and also this back into these equations here, and rearrange for ys become like this. So this one we factorize. So again, this one can be equal to 1, 3 over 4. You simply factorize this term, and for example, this one can be equal to, say, s. factorization of this one, you have to include all the possible single terms. For s squared, you have to split into s and s squared. For s squared plus 4, this is the second degree polynomial. So here you split it, you have to consider constant, also constant multiplied with the first degree here. And sometimes the people might miss this term. So that will make you result. You won't be able to find the number. So put everything together, then we can find the ABCD. So that will be equal to 3/4 s, and then let me multiply the e minus 3s coming in here. Okay, so we have those things. We simply do the inverse one by one. So for these terms, and again, we try to apply. You can see right now we have the. How about this? Let me rewrite the orders. So basically, this is minus 3s 1/s. Okay. So again, we simply utilize that information here. Let me write it up here. H t minus a f t minus a is the plus is e minus as times f of s. So from here, f of s equal to 1 of s here. Right now we have is this one, this side here. You compare. Okay, so that means here the a equal to 3, f of s equal to 1 of s. So from here we have the right information f of t equal to constant 1. So with those information we put back in, so therefore here is ht minus a equal to 3 and f equal to 1, so this one also equal to 1 here. So therefore this term, let me write it out, is equal to 3/4 and ht minus 3. Are we okay? Again, here I write it out is this theory. We simply try to match the necessary informations. I determine a equal to 3, f of s equal to 1 over s. Once we determine this, I calculate the f of t equal to 1. This one I look up from the tables, but right now I can memorize, so I look up from the table. So with those informations, we simply write it up, whatever this would be. So when t equal to a equal to 3, that is simply become this. And when f is a constant function equal to 1, so that means 1 will be constant anywhere. So I write it up, it's here. So that means here representing is the inverse Laplace transform of the whole thing, I write up here. One more time, we do this exercise here. For this one, and can I erase this? So for this one, look at here. Again, a maybe easier. I can swap the two terms. It will be easier to look at. Okay. So now compared to this one, you can see again a equal to 3. F of s equal to 1 over s squared. So from here, look up the Laplace transform tables. You can look at ft equal to t. With those things information, we can write it up. So the inverse of Laplace transform is t minus 3. ft, that is t minus 3 here. Okay, so therefore these terms will be equal to 1/4 here, and then multiply with t minus 3 and t minus 3 here. Okay, so for the remaining, do we have time? What is time now?
No,
Huh?
it's 11:20.
28? 2 more minutes. So let me try this one. So let me try this one. So again, for this one, let me swap the information. Let's compare. Okay, so for this one, again, a equal to 3. Let me write it up here, okay? A equal to 3, and then f of s equal to this one. So right away, we calculate the ft will be equal to, if you look at the tables here, that should be equal to 1/2 of sine 2t. And again, here I'm so familiar with, I write it down, but you can look up here, okay? So write it up, the h of this one, this will be equal to h t minus 3, f of t, that is times 1/2, and sine 2t, 2 times t minus 3 here. So for these terms, minus 1/4, that is coefficient here, and then h t minus 3, and then times 1/2 times sine, and 2 t minus 3. Got it? I just copy from there to here. And trust me, you can work on this one. This will give you is cosine 2t times half. And you can work on a similar process. Okay? So I believe, I haven't finished the slides yet, but I believe those ones should be good enough, at least for your homework. So maybe the remaining I will leave on you for your self-exercise. And Friday, we're going to move on to the physical models of the different systems. Thank you.